Department of Electronics and Communication Engineering. To his credit, I'll ask SAKTHIVEL to apprise all the things. Recently, he has published and granted a patent. So give him a big clap. Just 2 days before we received the thing. Yes. And after this session is over, you are free to ask the questions. The future of India is going to be in this area, that is the semiconductors. Whatever the thing that you use today, right from the mobile phone or a car or any other home applications, the semiconductors and the chips plays a major role. Electrical engineer வந்து நம்ம நினைச்சுக்கலாம் இது wire இருக்கு, transformer இருக்கு, இது இருக்குன்னு. அதெல்லாம் gone are those days, right? Okay, transformers are there. But future of the thing only depends upon the semiconductors and the chips. So it's a $1 trillion business. But though we are late, today we are having the Prime Minister's program on the foundation of the semiconductor fab systems. That's why you are being here, and hereafter we will focus more on the semiconductors, especially for the 3 branches, that is electrical, electronics and communication, and electronics and instrumentation. Okay. With this, I give it to our ARIIA coordinator and the Institute Innovation Council coordinator for the whole university, right? And the Multimedia Center Director and the Professor Dr. SAKTHIVEL, Professor of Instrumentation.
Good morning to all. Once again, I welcome you for this expert talk by JD sir. Actually, I will brief one of the things is going to be done by our Prime Minister Modi after this session. Okay, because the session starts by 10:30. Before that, I will briefly explain. Now I hand over the session to Mr. ARIVUDAINAMBI sir.
Round shape. What is that? Silicon wafer. Silicon wafer. Okay. So that is the raw material, basic raw material. We always process silicon wafers to make integrated circuits, chips. Okay. So now, today what is going to happen is, from 1960, our former prime ministers and the present government, they have been continuously trying to develop semiconductor fabrication in our country. Semiconductor fabrication in our country. Semiconductor fabrication means what? What you have to understand is, in 1947, when we got the freedom, right? In America, what happened? Can you tell me? In 1947. In 1947, when we got the freedom from English, in America, in the Bell laboratories, first transistor and amplifier was tested successfully. Okay? Now 75 years gone. So what happened is, in semiconductor manufacturing, in electronics manufacturing, US always had a high hand. Okay? But in 1947, you know how India was, right? Till at least 1980, India was struggling to feed all the people So the basic amenities. Can you tell me which technology we are very strong? In India, we are strong in something. What is this? Great. Right? So we are very good in what? Agriculture. So our prime ministers and former prime ministers and former governments, they were trying to develop all the agricultural systems and other infrastructure and so many things. But we couldn't somehow involve in semiconductor manufacturing. That has put us in India. Now because now today what happened, you take our day-to-day life, morning you wake up, right? First thing what you do is what? You check whether you have got any message in the WhatsApp. So everywhere you go, you do anything now, whether it is financial transaction, whether it is sending some circular, everything is what? All communications are through electronic media. Banking, electronic media. Medicine, any field you take, it is electronics. The second thing is what? Oil. Second thing is what? Petroleum. So, petroleum, we don't have anything. We don't have any resources. So, we have to what? Get it from other countries. But electronics nowadays, what is happening? That is what we are going to see today. India was struggling to start fabrication industries. But now, I am going to explain the financial aspects. What has happened is, we are importing electronics, we are importing oil. So that way, when we say a country is doing very well economically, when we say a country is doing very well economically, when we export more and import less. But what has happened today into India is, now we are importing more and exporting less. Especially in the present day, now we are 140 crore people. Imagine everybody has a smartphone. Everybody uses communication systems. Everybody uses computers. You can just imagine the volume of electronics we need. So that has put us in a very weak spot, because we have to import all electronics from other countries, because we don't have any manufacturing facilities in India, semiconductor manufacturing facilities, right? So first of all, what I am going to do today is, because at 10:30 our Prime Minister will appear in the screen, right? So he is going to inaugurate Tata Electronics Private Limited. They are first time in India, they are trying to develop semiconductor manufacturing facilities in India. Okay, so hereafter we are going to fabricate the electronics in India itself. Okay, that is an initiative. Right? So it's a milestone. So that function we are going to witness now. Before that, my aim is to just explain you why should we go for electronics manufacturing in India itself. Second thing, what is electronic manufacturing? Semiconductor manufacturing. So semiconductor manufacturing, the basic raw material is what? Say, silicon wafer. Silicon wafer, you know how silicon wafer is fabricated? So I will just explain you how silicon wafer is fabricated first, because that is the raw material. To start any electronic manufacturing, you need a what? You need a wafer. So silicon wafer, how it is manufactured, then how electronic circuit is fabricated, integrated circuit. So once you fabricate the integrated circuit, how we are going to package it? What we get in our hand is the final chip. The electronics is inside, the semiconductor part is inside. What we see outside is the packaging, plastic and connecting leads and other things, right? So these things I will try to explain you. The main focus for this talk is, you are all fortunate because you are going to live in an India which is a developed nation. I was born in 1967, where those days India was struggling to provide food for all people. Our Vice Chancellor used to tell in all functions. Right? When Indira Gandhi ji was the Prime Minister, most of the people they were trying, most of them, they didn't even have one time food. Most of them they went hungry to the bed. So their focus was to what? Increase what? Crop production. Okay? So you know our scientist, agricultural scientist, MS Swaminathan. So he smartphones, computers, mobile communication devices, in car, lot of electronics is coming, aircraft, everywhere. It is what available over there. What? Over there, top OTT platforms are available. So nowadays everything is what? Available in OTT, right? So AI and IoT, these are the new technologies that is coming up. So all of them need what? Electron. All of them need electron. Okay? Communication engineers should understand 5G. Now it is just coming up. So again, that will require a lot of what? New electronic circuits. Right? So now, this is the demand in the global level for semiconductor chips. Semiconductor chips. See, one thing you have to understand, engineers, we need to know not only the technology, we need to know the economics behind it, the commercial aspect of it. Okay? So now if you see the global sale of semiconductor chip, if you see in 2021, in the whole world consumed about $583.5 billion of semiconductor devices. Right? So that is 46,68,000 crore. Okay, 46,68,000 crore. 2025, they are expecting this will increase to what? 692.5 billion. So that is 55,40,000 rupees, 40,000 crore rupees. 2030, they are saying it is $1 trillion. $1 trillion. That is what? 80 lakh crore. 80 lakh crore. So now you see, in 2023, Indian economy, okay, 6 times more than our economy. Population is only 30 crore. We are 140 crore. Okay, so this much of business is happening in semiconductor industry. Now you come to Indian side. In 2026, right, India is expecting we will import 80 billion US dollar worth electronics. 80 billion. That is how much? 6,40,000 crore. In 2030, it will be 110 billion, right? So that will be what? 8,80,000 crore. You know, it will be almost equal to Tamil Nadu budget, state budget. Okay? So this much of money we are spending every year and we are giving it to foreign countries when we import what? Electronics. Right? So now you see, I just want to compare this with what? Now 2030, our projection is how much? 110 billion US dollar. Now in 2023, we imported 157.5 billion dollar crude oil. So this 157 billion dollar, that is 110 billion dollar. If you put together, around 2030, it will be 300 billion dollar we will be spending just on oil and electronics. Okay. So semiconductor import is also going up. Oil import, now everybody has a car. Everybody wants to buy big cars, right? Yes or no? Right. So per 10 kilometers per hour nowadays people are ready to buy. When I purchased a car, I was thinking it should give 20 kilometer per liter. Now 5 kilometer also people are ready to buy. So that means our oil import will increase. Electronics import is also increasing. $300 billion means you can just imagine. Okay, so most of our income we are spending on these things. So that means where is money for other development? Okay, so what we can do now? Oil you take. Oil we don't have any resources. But we have plenty of electronics engineers. We can, if we have our own semiconductor manufacturing units here in India, and if we manufacture the electronics that is required for India, what will happen? We will save $110 billion. So that much money will be what? Saved if you make electronics in our own country. So that is the major thing. Okay. So now what you need to understand, don't think that the people, right, our 1947, 1960, 1980, 1990, 2000, 2010, 2020 now, right? Don't think that governments are not aware of it. They were aware of it. But our problems were what? Different. We had to tackle other problems. So we couldn't concentrate much on what? Semiconductor manufacturing. Okay? So, next slide. Okay? So now you see, this is what I am showing, what 2017 to 2021. What was the import? Right? 2017, 3,64,250 crore. 2021, you see, it is 4,38,960 crore. Around $54.87 billion. Okay? In 2030, it is already projected how much? $110 billion. $110 billion means it will be almost double of the import cost. What we are importing now. Okay? So now where from we are getting this, you see. Listen carefully. Out of the $54.87 billion in 2021, $25.94 billion business we are given to whom? China. Because they are making lot of electronics. They are making lot of electronics. So what has happened? Out of our $54.87 billion import, $26 billion has gone to where? China. We are importing from Hong Kong. Hong Kong, you know, chota country. Right? Chota means very chota. Right? Okay. Vietnam, Singapore, Korea, USA, you see, we have spent, USA is now less. You have to see that. USA was leading the semiconductor platform in early 19. Okay, we have seen 1947, Bell Laboratories developed transistor. 1960, what happened? ARIIA. Cellular technology, same laboratory. Same laboratory. Yes or no? Right. So what happens, you see, we are all importing from these countries. They are much, what? In terms of knowledge, capability, those, what, economics and everything, they are much, what? They were much below us, but we are now, but what happened is, they got manufacturing units in their countries. So now we are importing from them. So if this trend continues, in a fine morning, right, our import bill will be so huge. Government will tell you, one person should not hold more than one cell phone. One, yes or no? Because otherwise what will happen? You can't, nowadays everybody has 2 cell phones, 3 cell phones, or lot of electronic gadgets if is starting. So now only what ultimately, if there is no manufacturing in India, ultimately import will also we have to cut down. Otherwise our economy will not be stable. So what will happen? You have to stop import. So that means we have to restrict usage of what? Electronics. That will hinder the other growth. Suppose imagine I won't use any computer in the bank. Now no banking will take place. I won't use any computers in the hospitals. Now no diagnosis will take place. Right? So that means ultimately we need to fabricate electronics in India. Okay? So in the early 80s, if you see, US was dominating. But what happened? China picked up very fast. Now China is leading the race. Because now the thing is, one wafer if you want to process and finally you package and get the electronic, get the integrated ICs. Suppose one IC cost is say $1. China is ready to give for $0.5. Because they have developed so much of facilities, they are ready to give. So US is not able to compete. Now India's problem is very difficult. Now we have to develop manufacturing, and at the same time that has to be what? Competitive. Market is very competitive now. You have to give manufacture and what? Give at for a lower cost. Okay? So that is why now what has happened, you see. They're explaining in a book. Okay. Why does India import semiconductors? Why this happened? Why this happened? Right? Basically what happens is that if you want to start an industry, you need capital investment. The businessmen, what they will do is, today if I invest 10,000 rupees, tomorrow they want 20,000. Or in a month they want 20,000. Huge margin with quick money they want to make. But if you invest huge money, because semiconductor manufacturing, all sophisticated equipments, when I talk about the fabrication process, you will understand, the equipments are very costly. So if you develop a manufacturing industry, you will invest say 60,000 crore rupee. Now, for getting back the 60,000 crore again back, it will take some time, maybe 5 years or 10 years. Then lot of revenue will come. But that much time we cannot work. The investors are not ready to wait. Not ready to wait. That is one thing. The second thing is the manufacturing of semiconductor that requires uninterruptible huge power supply. Huge power supply and the safety norms. Lot of chemicals are used, poisonous chemicals. So there are a lot of restrictions. You have to dispose the waste very carefully. Otherwise, it will pollute the whole earth. It will pollute the earth. So nobody is ready to start a manufacturing industry. So what in the early days, what our forefathers thought was, instead of making it, let us import it. It is cheaper. Because in 70s, the electronics was not very huge. Maximum we had radio. Marconi invented radio. 70s. Only after 90s and 2000 we had what computers and other things. So the electronics usage was increasing. Before that, so what our earlier administrators, government people, what they thought was, why we should waste money on putting large plants and what? Instead of that, because electronics import was very less than those days. So instead of making it here, we will import. Now the situation is different. Now we have to be alert. If you continue to import, one day our government will go bankrupt. Otherwise, we have to stop using what? Electronics. Okay? So that is what is happening. Now, now you see how semiconductor industry is developing in India from 1960. If you see, in 1960, Fairchild Semiconductors, they wanted to put a plant here in India. 1960, who was the Prime Minister? was the Prime Minister? And Sardar Vallabhbhai Patel. Okay. Vallabhbhai Patel was Prime Minister. Okay. Okay. Probably what? Mr. Jawaharlal Nehru. Okay. So in 1960, the Fairchild wanted it. Okay. But it doesn't work out. That means what? The expectation of the Fairchild company, Fairchild, Semiconductors is a very famous American company. They came here in 1960. We were having hydroelectric power plant. Okay. And in Tamil Nadu also in those days, 1960, getting power for all the 24 hours is not possible. Even now in Bihar, it is not more than 5 hours. I was in Bihar, I know. Okay. 5 hours if you get continuous power supply. So definitely, government should not have, because those days we didn't have thermal power plants, maybe hydroelectric power plant, a few power plants. Okay. So power situation was very bad. Lot of water is required. So such things should have what? Made them to what? So they went to? They went to Malaysia. They went to Malaysia. But what happened? Our people were intelligent in that aspect. For our military applications, frequency spectrum, for defense applications, we need the frequencies to be what? Confidential. So Bharat Electronics Limited was developed. How many of you visited Bharat Electronics Limited in Bangalore? Okay. So plan and industrial visit there, right? So in 1960, Bharat Electronics Limited was started. So they are making electronics for our own defense application. Our own defense, not for public use. Okay? In 1964, right? Again, Gurpreet Singh launches the semiconductor manufacturing company in collaboration with what? Continental Device Corporation of California. So we can't say there was no initiative. There were some initiatives. But as I told you, manufacturing, semiconductor manufacturing requires lot of water, lot of power. Okay? See, when I explain the manufacturing technology, you will know how much hydrochloric acid will be required, how much sulfuric acid will be required. So, disposal of waste has to be very carefully done when you make what? Manufacturing of what? When you manufacture semiconductor devices. Right? So now 1974, Department of Electronics realized the need to develop semiconductor design and fabrication. Where? 1974. 1976, this SCL you have to understand. That is in Haryana. Right? Semiconductors Complex Limited. So they have all fabrication facilities, but it is a research lab kind of thing. So they develop technologies for making electronics. They don't manufacture and sell it. Right? So it is again a government of India company. So in 1978, so they started at a cost of what? 15 crore. So that is why we missed the bus. With 15 crore, it was possible those days to get what? A plant formed, a semiconductor plant. Now we need 60,000 crore. Had we started that time itself, by this time, we were what? We would have been the what? We would be competing with what? China. Okay? So 1985, IIT Kanpur alumnus Prabhakar Goyal launches his startup. Okay? And specialized in making testing tool, Verilog and for chips. Okay? So they thought, okay, we won't be able to make chips. We will get the wafers and get it tested here in India. Okay, that is now happening in many places in India. Tata is doing. Our own alumni, one Mr. Veerapan, they have a company in Bangalore. They get the wafers, wafer level testing they do, and they give the certification. Because when you fabricate semiconductor devices in the wafer, if I make 10,000 devices, it doesn't mean that what all the 10,000 devices will work. Maybe 99%, sometimes 80%. So, if you have to test whether that is called yield. I am aiming at 1 lakh devices in the wafer, only 80% is giving. That means 20,000 devices not working. 20,000 devices are not working. Okay. So what happens is, such testing facilities people developed in India. There are some industries they are doing it, but still we have not started what? Manufacturing. Okay. In 80s, one of the IIC professor, Dr.S.ARIVUDAINAMBI, he is trying, but due to lack of government support, it doesn't work out. Things are going like this. Okay. In 2007, AMD came and they also, what? Government approved 24,000 crores. In 2007, I think it was who? Dr. Manmohan Singh. Okay. So 2007 it happened. 2005 again, right? Major multinational semiconductor companies attempt to set up their base in India but move away to what? China, right? Mohali plant is devastated by fire, causing significant damage. Of course, this was a very good effort by our late Prime Minister Indira Gandhi, right? But that was burnt when the manufacturing unit was developing. The whole unit was what? By some accident it got burnt. Okay. So now then 2012, that means government allocates 39,000 crore. Will do fast. That plan doesn't work out. 2013 to 19, there were many companies that were trying to put their plant here. 16, now 21, 19 also the Hindustan Semiconductor Manufacturing Corporation, they gave it up. They wanted to put their plant, but they gave it up because they wanted 50%, 60 out of 60,000 crore, 30,000 crore they wanted the government to give. But our government was not ready to do that, so that went. Okay, so 2021, now recent efforts. Now, the 2021, right, the Prime Minister Mr. Modi, he came with the Indian Semiconductor Mission. Indian Semiconductor Mission. So in the Indian Semiconductor Mission, his aim was at least we will invest $10 billion. Because our 2030, our import is how much? 110 billion. Now, $10 billion we will invest, 76,000 crore. Right? That was 2021. Now it is 83 rupees. So now it is 83,000 crore. They want to invest. They want to at least start now. Right? So in 2023, now today 2024, Tata Electronics Private Limited. Now they are doing the foundation stone. They are putting the foundation stone for building that manufacturing unit. Okay? So you are all fortunate. You are completing your degree when India is starting semiconductor. Lot of jobs. Okay? Lot of jobs will be there.
What are the bottlenecks? What are the bottlenecks?
Even now, there will be lot. Now, I don't think power is going to be a big problem, but I am still doubtful whether we will be able to dispose the waste properly. Because in America, I know what is happening. Because I have my friends and my own son is there. He is working in manufacturing industry. They are very careful. They won't take any chance. But here, we know what we do. Vessel chop ko depi chop raho. Chop it, apni table le put. Okay? Idhe na energy mo. Chemical le padu. Okay? Yeah. Seta poranda. Konja poisonous gas la put veliye. Idhu ellam proper pollution free pananona neriya adukku invest pananum. Yes or no? If we have that mindset, you please understand, our ancestors might have been something like that. You cannot be like that. You have to be very health conscious. Safety is very, very, very important. Okay? When you join the manufacturing industry, semiconductor manufacturing industry, you please be careful. Right? You see that the wastes are disposed very safe. Very safe. I don't know, China, they are making a lot of semiconductors now. But I don't know whether China, they are not bothered. They want what? Money. Okay? Follow my point on that. So our rules have to be very tough, especially in the safety norms. Okay? So because what happens, I invest about 10, 60,000 crores, 70,000 crores. And out of that, 20,000 crores, is for safety things, right? So what they will think, 40,000 crore, I will finish the job. கொஞ்சம் ஹைட்ரோக்ளோரிக் ஆசிட் தானே அப்படி அரபிக் சீல விட்டுருவோம், மீன் கொஞ்சம் மீன் சாகும். ஓகே, அப்படி இருக்கக்கூடாது, இருக்க ஓகே. ஏற்கனவே ஆயுசு குறைஞ்சிட்டு இருக்கு. 90 வருஷம் 100 வருஷம் இருந்தாங்க, இப்போ 70 மேலே போக மாட்டேங்குது. நீங்களாம் 40 போயிருவீங்க, அப்படிங்களாம் சாப்பிட்டீங்க. இதுதான் புரியலையா? Right? So that is the thing, right? So now this Indian Semiconductor Mission, they have these schemes now. They have. What I want to tell you is, please, you have to, as engineering graduates, you should know what is happening in the country and how I should prepare myself. Semiconductor industry, if you want to join as a production engineer or a design engineer, what are the technologies you should learn? Now we have introduced a lot of elective subjects. At least there are 7 elective subjects in our curriculum. You can take those subjects. And we were running a program on microelectronics and hence ME program. Of course, now it is, the students are not there. But, right, the students who completed that, the PhD in that area, now they have got good jobs. They got some good jobs. Now when these industries come, lot of requirement will be there for what? Electronics engineers who know semiconductor fabrication technology. Okay, if there is time, I will explain all those things. Otherwise, after the Prime Minister's program, I will talk for some afternoon. Okay, if you are interested. Otherwise, we will have it on some other day. Right? Okay. Right. Our Prime Minister is taking a lot of initiatives to do that. Right? Because they know now, if we don't do it today, we are going to lose. Okay. Follow my point on that. If because everything is what now? Semiconductor devices. That is why electronics engineers need to be very proud of now. Because semiconductor, silicon is ruling the world. What is basically silicon? Money. Right? Okay. It's available plenty. If you go to NLC, lot of silicon. Okay. So now in India, when this happens, what and all will happen? I tell you. The first thing, nowadays the semiconductor manufacturing industries, they are importing wafers from other countries. Wafers. First thing what we need to do is, now what happens? I take the wafers from China or something. A wafer cost is what? Around 1,200 rupees. One wafer that he was seeing, that is how much? 1,200 rupees, one wafer. Now, if an industry is processing 1,000 wafers per day, 1,000 wafers per day, 1,000 into 1,200. So first thing, to start with, we can buy wafers from outside, we can fabricate integrated circuits, package it and sell it. But ultimately, the wafer also should be what? Fabricated here. So first thing what you need to understand is how silicon wafers are manufactured. The second thing, what are the semiconductor processing techniques available that will make, now I don't know whether you know, but EC students, I have explained how a diode is made. Okay, the silicon wafer you take. How will you convert this into p-type? Silicon wafer is intrinsic basically. How will you convert this into p-type? You have to add trivalent impurities. Trivalent impurities are what? Aluminum atoms or boron atoms. Boron atoms 2 tablespoons. That is not possible, I have told you. What we do? We have to do diffusion. Okay, so ion implantation, there are techniques, right? So you can convert intrinsic silicon into what? P-type or N-type, and silicon dioxide. Silicon dioxide. See that again, right? But IIT Madras and IIT Bombay, IIT Delhi, IIT Kharagpur, all these institutes, IIC Bangalore has a 300 crore fab lab. IIT Madras, it is around 150 crore. They have invested. They have the fab lab. So I was there for 5 years in IIT Madras, right? So when I was there, it was just developing. Now it is very well developed. So you can learn how to fabricate an integrated circuit if you go there and do your MTech. So when you want to do MTech, what is required? A gate score is required. So you have to prepare. See, one thing I want to tell you, when you think about a gate, if you directly go and appear for gate after our UG program, it is difficult because I know how you solve problems, right? Okay, simple problems also you really struggle a lot. So what you can do is, you can join some gate coaching, 1 year or something. There is nothing wrong. If you over, suppose imagine you are going to be alive for 75 years and 21 you will be completing your BTech. 1 year if you work hard and if you go for some gate coaching, 22, then another 2-3 years you are MTech, then you will get a job. So this 1 year, it is not going to change your it's worth spending 1 year for gate coaching. When you do that, you will be able to definitely clear gate coaching. You will be able to get good score in gate. And if you join these institutes, definitely in this area, if you want to develop, you will get very well developed, and in future there is good possibility. See, one thing you have to understand. Today, software job, if you go, those days in 2000 to 2024 now, around 20-25 years, software was doing very well. Now software, people are not getting very good salary. But here, if you join this fab, 12 lakhs per annum and all, it is very simple. Only thing, you have to be there in such institutes. So you have to qualify gate examination. So you think about that and join some industries. Our institute also, you choose the elective subjects that we have already given, especially ECE students. I think there are some 6-7 courses, elective courses. So when you do 7 semester, 8 semester, you can choose the electives in that area. So you will, especially VLSI technology. There is a paper called VLSI technology that completely teaches you how to fabricate a semiconductor chip. Okay, so you have to do that course. Right? It is very simple for ECE students comparatively. I won't say that E&I students and electrical students won't understand, but ECE students will have a cutting edge when you want to do semiconductor fabrication, because we do a lot of electronics, right? So you can think about that. Today, since we have come all the way now, whatever I have discussed in the beginning, it was all commerce, economics. So I will take 10 minutes. I will just tell you how a semiconductor wafer, the wafer that you have seen today morning, that is a 4-inch wafer. A 4-inch wafer, if you process, 4-inch you can calculate. The diameter is what? 4-inch. So you can calculate the area, and if the chip takes 1 mm by 1 mm, 1 millimeter square, you can find out how many chips you can get in that wafer. Okay? So that is a major advantage of semiconductor processing. I used to tell semiconductor processing, it's like making idlis. Italy is cheaper. Dosa is costly. Why? The same amount of what is it? Yeah. So why it is costly? Italy is batch processing. Batch processing means at a time 3 stack 4, 4, 4, 12 idlis you will get. So the gas consumed you calculate per making 1 idli. That will be 1 dosa, right? Sequential processing. So we are communication engineers, we know that what parallel processing is faster. Sequential processing is slower. Okay. So dosa is costly because the fellow has to make 1 by 1. அதனால தான் எங்கள் வீட்டிலலாம் பார்த்தீங்கன்னா ரைட்டு அம்மா செஞ்சு தந்துருவாங்க. ஒய்ஃப் என்ன சொல்லுவாங்க, தோசை வேணுமா இட்லி வேணுமான்னு கேட்பாங்க. நீங்கள் தோசை சொல்லிக்க கட்டாயம் தோசை வேணுமா? ஏன் இட்லி கொஞ்சம் குயிக்காக பண்ணிடலாம். ரைட். ஸோ பேட்ச் ப்ராசஸிங். ஸோ 1 wafer if you make, 1 wafer if you process, at a time you are going to get 10,000 chips. Or 20,000, you have to do the calculation. Total area divided by chip area. Okay. So that is why integrated circuits are cheaper. Integrated circuits are cheaper. So because we go for what? Batch processing. So now quickly I will do. I just take 10 minutes. I will tell you how sand is converted into silicon wafer. That's all. How sand is converted into silicon wafer. Silicon, okay. Sand is basically what? SiO2. SiO2. Silicon dioxide. Silicon dioxide. Now this O2 you remove. Silicon dioxide. SiO2. You make it Si plus O2. Gas will escape. Silicon you will get. Yes or no? So now the silicon what you are going to get, that is going to have a lot of impurity because sand is what you will collect it from neighboring mines. So that will have iron particles contamination. So but I have told you, intrinsic semiconductor means what? Semiconductor in its pure form. That means what? Not even a single atom of other material should be present there. So what we get first is metallurgical grade silicon. Metallurgical grade silicon. But what we need for semiconductor processing is electronic grade silicon. Electronic grade silicon. All atoms must be what? Silicon atom. There should not be any other impurity atoms. There should not be any other impurity atoms. So I quickly go through. I mean, a few slides. Right? I know you are all really disturbed. Right? But at least we have come all the way here. We have assembled here. Let us learn at least a few things and go. We have started this morning. I mean, I didn't talk much about technology. I was talking about what the economics. Right? So how silicon wafers are made, that we will learn. Right? Okay. So if you want to make a silicon wafer you have seen. You could see your face. That's a polished wafer. One side polished. Okay. Why it should be so smooth? If it is, if the surface is not even, the electrons when they move, there will be lot of scattering. So surface must be what? Smooth. That is why you are able to see your what? Face. See your face. Okay. Follow my point or not? So we will just quickly see, right? So now this quartzite to metallurgical grade conversion, that is the first thing what you are going to do. Okay? I will take SiO2, that is sand basically. Okay? I will take that. I will first convert that into what? What? Metallurgical grade silicon. Okay? Then there is a process called Siemens process that converts the metallurgical grade silicon into polycrystalline silicon. Okay, what is polycrystalline silicon? I tell you. Right, that is pure form, but still it is not monocrystalline. Okay, so finally there is a chocography process that converts polycrystalline silicon into what? So the first thing, quartzite or silica, if you take that is SiO2, that has to be what? Converted into silica. SiO2 has to be converted into silica. Okay, so this is the process diagram. Silica is SiO2. There is a electric arc furnace. The electric arc furnace will convert the silicon dioxide into metallurgical grade silicon. That metallurgical grade silicon will be given to a fluidic wet reactant. Fluidic wet FBR. So there it is converted into what? Polysilicon. And then polysilicon will be finally converted into what? Monocrystalline silicon. Polysilicon, monocrystalline silicon. That is very difficult topic. I mean, now time is not sufficient to teach you all those things. Maybe in the class I'll teach you sometime. Okay? So, three process. First, silica is converted into metallurgical grade silicon. Metallurgical grade into polycrystalline silicon. Polycrystalline into what? Monocrystalline silicon. Okay? So that is 99.999 pure silicon. Only that can be used for what? Okay? Pure silicon, purest form. The purest form. Okay? So we'll see first what we have, what I do. See, silicon dioxide is reduced by heating it with coke or charcoal at the 2000 degrees Celsius in an electrical furnace. So the silicon dioxide, the melting temperature is 1400 or 1500 degrees. Okay? What is the melting temperature for aluminum? Aluminum 450 degrees. This is what? So I take the sand, okay, and I will heat it up to 1500 degrees Celsius. When I do that, what happens is the O2 will go, I will get what? Silicon, that is but it is only 98 to 99% pure. It is called metallurgical grade silicon that has contained impurities like what? Iron, aluminum, titanium, boron, chromium or something. Okay? Okay. So this I think this chemical equation we will forget. So now what you see? The silicon dioxide is heated up. First of all, it is converted into what? SiO and CO. That is carbon monoxide. Then again at 1600 to 1700 degrees Celsius, when you do that, you will get what? Silicon carbide. The silicon carbide is again added with SiO2. When you heat it, you will get SiO. So what you get is what? Metallurgical grade silicon. Metallurgical grade silicon is easily available, but it is not pure. That is used in automotive. Most of the automatic car industry or automotive industry, right? They use metallurgical grade silicon for making engines and other things, right? Okay, so this is basically a metallurgical grade protection unit layout. Okay, so the raw material is carbon, charcoal or something, and SiO2. There are electrodes that will heat it up to 1700 degrees Celsius. So you get ultimately what? Silicon, but it is metallurgical grade silicon. Now next. Now what I am going to do is the metallurgical grade silicon. See the top portion, that is metallurgical grade silicon. Bottom, the red color stuff, what you see is what? Hydrochloric acid. So I put it in a reactor, and what I am finally going to get is what? Silicon hydrochloric. Okay, SiHCl3. Okay. So heating metallurgical grade silicon at 300 degrees Celsius in a current of HCl3 in a fluidized wet reactor is what? This is what? Gas. Okay. So or liquid. Okay. So now next. So now what I am going to do is, this time vaporizing, you put a rod, a silicon rod, you vaporize this Si, what? HCl3. The chlorine will get separated, hydrogen will get separated, the silicon particles will go and deposited in the what? Rod that I am going to keep. Okay? That's correct. I will keep a silicon rod. There these particles will go and what? Get deposited. For example, when you do ionization, the carbon, when you want to electroplating, when you want to do electroplating, what do? You put the metal inside the electrolyte, positive, negative. So this copper particles will go and get deposited beautifully in a what? As a thin layer. Something like that. The rod is getting rid of silicon particles. Okay. Now these silicon particles are getting deposited in a what? Rod. So that is polycrystalline in nature. Polycrystalline in nature means it is arranged in different orientation. Okay. So now next. Okay, you see. So there are different orientation. 1,0,0,1 million indices you studied in physics. Million indices. Okay. So finally, this polycrystalline silicon, okay, that what I am going to do is, by this Dr.S.ARIVUDAINAMBI process, I will get what? Melt the polysilicon. Okay. I think the next, okay, this polycrystalline silicon again melted at high temperature. Now what I am going to do is a hollow cylinder you take. Hollow cylinder. இப்போ கொஞ்சம் யோசிச்சு பாருங்க. நீங்க வந்து ஒரு பெரிய பாத்திரத்துல நல்ல தோசை மாவு வச்சிருக்கீங்க. ஓகே. இப்போ வந்து அதை நல்லா சூடு பண்ணுங்க. அதுக்குள்ள ஒரு ஹாலோ சிலிண்டரை இன்சர்ட் பண்ணுங்க. இதை அந்த எவாபரேட் பண்ணுங்க. என்ன செய்யுங்க அந்த மாவு அப்படி மேலே போகுமா அந்த சிலிண்டருக்குள்ள போகக்கூடாது. Same thing. What I am going to do is I will melt the polysilicon. Now it is in collider state. Now what you see in the top is what? All impurities. So that will get separated. Now a pure silicon will be, when I immerse the hollow cylinder, that will raise. Okay. So I am beginning that is called what I should do is, first of all, when I want to go, initially I will put a small quantity of silicon in that. So all the silicon will get what? Connected to the silicon crystal. So when I raise it, all pure silicon will raise. And they will move up in the cylinder. Now what you do is, the whole cylinder, you cool it down and open it, you will get a what? Long cylindrical hard silicon. Okay, now it is pure silicon. That is called ingot. Ingot means what? Lithophorezia. Okay, now what I have to do? I have to slice it. Okay? Now you see, the silicon ingot that is cylindrical in nature, it may be 4 inch or 10 inch. I have to what? Slice it, then grind it till the surface becomes what? Okay? So this is how silicon wafers are. That is the raw material for making what? Semiconductor chips. Now, how to process this silicon wafer? That is a big thing. Okay, how to make a MOSFET? How to make a MOSFET or how to make a diode? And all our, for example, you take a CMOS inverter. That has 2 MOSFET and other resistors and other things. So that and all we will teach you. I think VLSI technology you have done a portion of it. Okay, so you know that. Okay, so Now what we need to do in India is what? We have to fabricate silicon wafers here itself. Then we have to start fabricating silicon chips, microprocessors, microcontrollers, and a lot of other what? For communication we need what? Modulator, demodulator, transmitter, receiver, so many things. When we make it in India, we will be saving a lot of money. And people will get job. That is very important. When some technology develops, what happens? People get job. Okay? Yes or no? So I thank you all for your patient listening. I think engineering is not a joke. Engineering is not a joke. It is something serious. Something